Welcome to Session 1 of Restriction Fragment Length Polymorphisms, abbreviated as RFLPs or more popularly known as RFLPs. RFLPs are DNA-based molecular markers that assist differentiation between individuals of the same species, like in humans, or different species of the same genus, as that between a coyote and a gray wolf. So what exactly are RFLPs? Restriction fragment length polymorphisms or RFLPs carry their definition in their name. A restriction fragment is a piece of DNA that is excised from the larger DNA molecule by an enzyme called a restriction enzyme or restriction endonuclease. The polymorphisms are determined by the number and the varying lengths of these DNA fragments produced. If two organisms differ in the distance between sites of cleavage of a particular restriction endonuclease, the length of the DNA fragments produced upon digestion will obviously differ. The similarity or dissimilarity of patterns generated can be used to differentiate species and even strains from one another. The specificity of restriction enzymes is such that the replacement of even a single base in a site is enough to prevent the enzyme from cutting the DNA at that site. It is this specificity that is exploited for detection of polymorphisms. To detect a restriction fragment length polymorphism, there are a number of basic steps to which multiple technologies and protocols have been applied. The DNA must first be isolated from the organism or cell of interest, whether that be a prokaryote such as a bacterium or a virus, or a eukaryote such as human cells, with protocols varying depending on the source of the DNA. After isolation, the DNA is treated with a restriction endonuclease, and the resulting fragments are separated by agarose gel electrophoresis embedded with ethidium bromide stain and then visualized under UV. A sudden blotting is then carried out, where the fragments on the gel following denaturation are transferred to a nitrocellulose or nylon matrix. The blotted DNA is then hybridized with specific radiolabel probes or fluorescent label probes. This step is essential since on the agarose gel, numerous fragments of varying lengths are obtained, and the range in size is rather continuous so that they form a smear on the gel, making detection difficult. Detection for radiolabel probes follows exposure to X-ray films, developing and fixing to obtain autoradiograms. Detection for fluorescent probes depends on the type of labeling done, that is, whether it is direct or indirect labeling. Having understood the procedure of RFLP analysis, let us consider one of the more popular applications, that is DNA fingerprinting. Since the RFLP pattern for each individual is different, you and I have a very distinct DNA fingerprint. This distinctiveness comes handy in paternity testing and even in criminal investigations. Presented here is an example of how RFLP DNA fingerprinting can be used for criminal investigations. The lane on the left represents the RFLP banding pattern observed in the DNA sample retrieved from the crime scene. In the following lanes, the RFLP patterns of three suspects, namely suspect 1, 2, and 3, are presented. On careful observation, you notice that the banding pattern of suspect 2 is an exact match to the DNA found at the crime scene. Thus, suspect 2 is the most probable culprit here. Having understood how RFLPs can be used in forensic science and in DNA fingerprinting, are you therefore all set for an investigation? Don on your detective cloaks and pick up your magnifying glasses. Let's investigate a sexual assault case using RFLP. Presented here is a case where a female was sexually assaulted by a male other than her boyfriend as claimed by her. Samples of DNA from two suspects fitting her description have been collected. Further, evidence collected include sample from the victim and sperm DNA found on the victim. Additionally, the police have also collected DNA from her boyfriend to confirm her claim. All the samples were digested with restriction enzymes, and following southern blot and hybridization, the reflip patterns were obtained as follows. Who do you now think is the most probable offender of the three males? Suspect 1, Suspect 2, or her boyfriend? Well, I assume you've guessed it correctly. It's indeed Suspect 1, since the reflip pattern of the sperm DNA found on the victim matches with the DNA of Suspect 1. I do hope you found the investigation interesting. Do revise these concepts before we meet for our next session. Goodbye till then, and have a nice day.